The ɡຄໍɛ́ɡɔrczyk hierarchy, named after the Polish logician Andrzej Grzegorczyk, is a hierarchy of functions used in computability theory. Every function in the ɡուցɛ́ɡɔrczyk hierarchy is a primitive recursive function, and every primitive recursive function appears in the hierarchy at some level. The hierarchy deals with the rate at which the values of the functions grow. Intuitively, functions in lower level of the hierarchy grow slower than functions in the higher levels. Definition. First we introduce an infinite set of functions, denoted a for some natural number I. We define in, i.e. e0 as the addition function, and e1 as a unary function which squares its argument and adds 2. Then, for each n greater than 1, we define, i.e. the xth iterative evaluated at 2. From these functions we define the ɡուցɛ́ɡɔrczyk hierarchy. The nth set in the hierarchy contains the following functions: ek for chi less than n, the 0 function equals 0, the successor function equals x plus 1, the projection functions compositions of functions in the set, and the results of limited recursion applied to functions in the set. In other words, is the closure of set with respect to function composition and limited recursion properties. These sets clearly form the hierarchy because they are closures over the S and they are strict subsets. In other words, because the hyperoperation is in but not in, includes functions such as x plus 1, x plus 2, provides all addition functions, such as x plus y, 4x, provides all multiplication functions, such as xy, x4, provides all exponentiation functions, such as xy, 222x, and is exactly the elementary recursive functions, provides all tetration functions, and so on. Notably, both the function and the characteristic function of the predicate from the clean normal form theorem are definable in a way such that they lie at level of the ɡուցɛ́ɡɔrczyk hierarchy. This implies in particular that every recursively enumerable set is enumerable by some function relation to primitive recursive functions. The definition of is the same as that of the primitive recursive functions, Rp, except that recursion is limited and the functions are explicitly included in. Thus the ɡուցɛ́ɡɔrczyk hierarchy can be seen as a way to limit the power of primitive recursion to different levels. It is clear from this fact that all functions in any level of the ɡուցɛ́ɡɔrczyk hierarchy are primitive recursive functions, and thus, it can also be shown that all primitive recursive functions are in some level of the hierarchy. Thus in the sets partition the set of primitive recursive functions, PR, extensions. The ɡուցɛ́ɡɔrczyk hierarchy can be extended to transfinite ordinals. Such extensions define a fast-growing hierarchy. To do this, the generating functions must be recursively defined for limit ordinals. If there is a standard way of defining a fundamental sequence, whose limit ordinal is, then the generating functions can be defined. However, this definition depends upon a standard way of defining the fundamental sequence. Rose suggests a standard way for all ordinals alpha less than epsilon 0. The original extension was due to Martin Loeb and Stan S. Wehner and is sometimes called the Loeb-Wehner hierarchy.